Welcome everyone. Let's talk about exponents. Natural number exponents. We define natural number exponents as x to the power of n is equal to x multiplied n times. Let's see some examples. X squared is equal to x multiplied with x to the power of 4 is equal to x multiplied 4 times, y squared x cubed plus z squared can be written as y multiplied with x by x plus z multiplied by z. 0 is an exponent. X to the power of 0 will be equal to 1 for any x is not equal to 0 real number. 0 to the power of 0, this is not defined. Negative integer exponents, if we have, this is wrong. Instead of this, we have to write x to the power of negative n is equal to 1 over x to the nth power. 0 to the power of negative n is not defined for any positive integer n because you cannot divide 1 with 0. Example, x to the power of negative 3 is equal to 1 over x multiplied by x multiplied by x. X squared z to the power of negative 2 can be written as x by x over z by z, or x squared over z squared. Rational number exponents. X to the 1 over nth power is the nth root of x. If n is odd, x to the 1 over n is the unique number y, which when raised to the nth power gives x. For example, 8 to the power of 1/3. This is equal to 2. Why? Because from the definition, which number cubed, which is my here nth, which number cubed is 8? It's clearly 2, therefore this is equal to 2. If n is even, if x is greater than 0, x to the power of 1 over n is the positive number, which when it's raised to the nth power, it gives x. Now we have to be careful because if x is equal to 0, then x to the power of 1 over n will be 0. If x is less than 0, x to the 1 over n will not be a real number. And again, we have some examples. 8 to the power of 1 over 3, as we said, this is equal to 2 because 2 cubed is 8. You can think this in another way, which is 2 cubed to the power of 1 over 3, and by the properties that we will see, this is equal to 2. Same for the following examples. Properties, these are really common. I'm pretty sure all of us know these at this point. X to the power of a multiplied with x to the power of b is x to the power of a plus b. I did not wrote all because other properties you can figure it out from the properties that we have here. And lastly, scientific notation is really important because sometimes instead of writing all of those long zeros, we just want to write it as an exponent, which helps us a lot. Alright, now let's see our examples. Simplify the expression. First thing I want to do is instead of the 8 here, I want to write 2 cubed x to the power of minus 6. This is to the power of 2/3. We will have to distribute the 2 over 3 like this. From the rules, from the properties, we have to multiply the powers here. 2 squared multiplied by negative 6 multiplied by 2 over 3, negative 4, which gives me 4 over x to the 4th power. Simplify the given expression. Let's see what can we do. I need to distribute the power again. 2 cubed a to the 6th power, b to the power of minus 9 over 4. Instead of 4, maybe writing 2 over 2, 2 to the 2 squared would help us. A to the power of negative 4, b to the 5th power. One of the 2's will remain. Instead of, let's divide the like terms. this is equal to a to the 6th power multiplied by a to the 4th power, which gives us a to the 10th power. From the second part, b to the power of minus 9 over b to the power of 5, which gives us b to the power of negative 14. Let's write that as a denominator, is my answer. Factor out the lowest power for x. Okay, let's see for the term expression given to us. Of course, I see x to the power of 1 over 2. This is also equal to square root of x, but let's write it in this form since the problem is given in this form. Plus x is going to be my answer. Simplify and write positive exponent for the given. Okay, I have a negative 2, but I don't want that. So therefore, instead of this, let's write x squared plus y squared squared. Now I need to know a plus b squared is equal to a squared plus 2ab plus b squared. From that, I get x to the 4th power plus 2x squared y squared plus y to the 4th power. Evaluate the given expression. Let's see what can we do. I see an m square here, I see an m to the 4th power here, and there's a negative m to the 5th power. When I multiply these, I get m to the 6th power, so I need to multiply negative m to the 5th power by m to the 6th power, which gives me negative m to the 11th power. What is the 1 or 1/3 to the 6th power multiplied by 81 equal to? Okay, let's think what we can do. First of all, instead of 3, if I write 1 over 3, if I write 3 to the power of negative 1, and this is to the powers of 6, so therefore this is 3 to the power of negative 6. Instead of 81, I can write 3 to the 4th power. Now I can add the powers, which gives me 1 over 9. 5 to the x plus 4 times 5 to the x is equal to 4 over 5. Solve for x. Instead of this, we will write 4 multiplied by 5 to the x is equal to 4 over 5. I will divide both sides with 4. So now 5 to the x is equal to, what is 5 to the x is equal to 1 over 5. From here, x is equal to negative 1. Simplify, wait, isn't 7, 9, what? Problem 8, our last problem. Simplify the given expression. Let's see. Of course, first I need to distribute the power 2 to the power of 3x plus 3 over 3 to the power of 3y multiplied by 3 to the power of 3y plus 3 over 2 to the power of 3x. Now I see there's a 2 to the 3x here, 2 to the 3x here, but there's a plus 3, so I need to write in a different form. I know that I can write this as 2 to the 3x multiplied by 2 cubed multiplied by 3. Let's separate this part as well. Multiplied by 3 cubed over 3 to the power of 3y multiplied by 2 to the 3x. Canceling the terms we can. From here, I'm left with 2 cubed multiplied with 3 cubed, which is equal to 6 cubed. That is equal to 216.